This is Fit to Succeed with host Ben Pratt.
So that means after waking up, we should wait at least 1 to 2 hours before our first meal. Because if we eat too close to waking up, then our pancreas is not ready to process that carbohydrate, and almost all of our food has some carbohydrate, and it doesn't take too much carbohydrate. Just 1 or 2 grams of sugar or carbohydrate is enough to trigger the pancreas to produce insulin.
So I'm excited to have Dr. Sachin Panda with us live today. He's calling all the way from California. Dr. Panda, welcome to the show.
Thank you. Glad to be on your show.
Thanks very much. Now, I want to get straight into it. And if you don't mind, Dr. Panda, you're really well known for your research in the field of circadian rhythms, which is those rhythms that work around the 24-hour clock. If you could summarize the importance of this concept of physiological rhythm around a 24-hour clock, and I only give you 1 minute as a maximum, what would you say to us?
Well, actually, circadian rhythm, I would redefine it as a field of science that studies the human peak physiological, physical, and emotional performance in every hour of the 24 hours day. And the reason is every hormone, every digestive juice, and even every gene turns on and off at specific time of the day. So if we nurture our circadian rhythm, then we can get the benefit of these timed activities for our mental, emotional, and physical health.
Excellent. That's a great bit of feedback there. Really appreciate that. Now, you've linked that there to sort of mental, emotional, and physical health. And, I'm hoping today as we get into this, we'll be able to pull on some of those concepts, some of those ideas of how our 24-hour cycles feed into those different aspects of human health. So just to get to know you just a little bit better, I know you've been doing this work for a long time, but what was it that originally inspired you to specifically study circadian rhythms and how they impact human health?
Well, for the last 100 years, we have been studying how gene X or hormone X affects our health. But we know that we humans are not the same creature between the middle of the day and middle of the night. So that means our physiology, metabolism, everything changes between day and night. And I wanted to study the biology of this timing phenomena, or biology of time, instead of biology of genes and hormones. So when we think about timing, there's only one universal timing concept that's conserved, that's evident in every living organism, almost every living organism, starting from pond scrum to humans and elephants, and that's this 24 hours rhythms. And what is interesting is if we disrupt this rhythm, starting from, say, pond scrum to humans, we reduce performance, physical, and those who have, like organisms with a brain, the brain function, and also reduce lifespan. So this was very intriguing, how disrupting just the timing can have such a huge impact on fitness and longevity. So that's why I got into this field of circadian rhythms.
Yeah, that's fantastic. Now, that really fascinated me that you said there that even down at some of the lower life forms, the algae, things like that, even they have a 24-hour rhythm. Did I hear that right?
Yes. In fact, the reason why we have higher life form on this planet may be due to this photosynthetic microbes that float in the ocean or in pond and fix carbon dioxide, because when they have circadian rhythm, that means they can anticipate when the sun is going to go up. They can turn on the photosynthetic machinery an hour or two before sun comes up, so they are ready to harvest the sunlight. And same thing, at the end of the day, they can anticipate when sun is going to go down and can shut down all this machinery. So the estimate is by having circadian rhythm in photosynthetic microbes and photosynthetic organisms, in the early days on this planet, these bacteria and plants could fix 10 to 15% more carbon dioxide.
Wow.
And in that way, we think that maybe the reason why higher life forms evolved on this planet is because of the circadian rhythm in lower life forms.
Mm-hmm. That's really fascinating. That really is. So you reckon that's been part of our evolutionary biology right from those early days.
Yeah.
Fantastic. Now, obviously, we're going to talk mainly about human impact and human health with regards to this 24-hour cycle. And I just wanted to try and get a sense of how strongly tied human beings are in their physiology to that 24-hour cycle, to the light-dark cycle that we go through on a daily basis. So to what extent does our health rely upon these cycles?
Our health greatly relies upon these cycles because we humans evolved on this planet almost 200,000 years ago, and there's only one constant between our early days and now, and that's this 24 hours light and darkness. So that's why our body is designed, even it's imprinted in our DNA, to go through this 24-hour cycle. Because during daytime, the temperature rises, there is light, so we can go out. In the old days, if you're a hunter-gatherer living in the jungle, then it's safe to venture out during the day. So these are all integrated into our system in a way. So for example, even if you try to sleep for 8 hours during the day, it's really hard to get uninterrupted 8 hours sleep because we're designed to sleep at night. Mm-hmm. Similarly, that's just the tiny tip of the iceberg, because almost every hormone, enzymes, and genes in our body are designed or pre-programmed to switch on at certain time. And if we look at shift workers who work in night shift or morning shift or evening shift, sometimes they can go on the same shift for 10 or 15 days at a time, but still the body doesn't adapt to this artificial shift. And we know that shift workers are at a very high risk for many chronic diseases, to the extent that World Health Organization has actually classified certain forms of shift work, for example, firefighters who do shift work. So this night shift work is a potential carcinogen. So staying on the night shift work can increase the risk for cancer. So these are some epidemiological data from humans that say that if we live outside our circadian rhythms, then we increase our risk for chronic diseases, and which in turn will reduce our lifespan. Mm-hmm. And in laboratory cases, we can carefully control many conditions. For example, people may argue that if you're working night shift, you may not have access to healthy food. You may also be sleep disrupted. You may have extra stress. So in laboratory animals, if we simulate shift work, we also see very similar physiological disruption and disease. For example, when we subject laboratory animals to shift work-like paradigm, they are at a high risk for many types of cancer. They gain weight. They're also more susceptible to bacterial infection, and they're more likely to die from sublethal dose of infection. So all of these, both controlled clinical and laboratory studies and epidemiological studies, are telling us that these rhythms are extremely important, and we just can't afford to disrupt them because they're already encoded in our DNA. We cannot change our DNA to make us arrhythmic or go whenever we want. We can just go to sleep and wake up and do our stuff.
Mm-hmm, mm-hmm. Now, it was interesting as you were talking there about shift work, and I was thinking about the industry that I work in, which is health and fitness. And in more modern times, we're seeing gyms that are open for 24 hours a day so that people can go in the nighttime to try and, help the shift workers still exercise. And even you're saying there that despite, those adjusted rhythms that they're striving to overcome, what's the potential impact for someone who's trying to exercise in what should be their nighttime, but might be their shift working daytime?
Yeah, so shift workers, they can use exercise at nighttime to their advantage. For example, in San Diego, the city where I live in, the police officers, they stay on the same shift for 3 months.
Right.
So that means they have long time to really adjust to, say, night shift or day shift. And for them, it's actually works extremely well to do some exercise at night. And I know some of the police officers, they will just go to a park. If they have little downtime, do some 50 push-ups or jumping jack, and then they'll move on. And they think that that's their energy boost that keeps them active throughout the night. So similarly, people who work in night shift, they can use exercise to their advantage, and there is nothing wrong about it. Just imagine they're just living kind of in a different time zone for a while. For shift worker, the biggest challenge is to shift back and forth between night shift or say early morning shift and your regular day job. And that's, I mean, the social life that people live in the weekend. And so going back and forth between your shift work and your social life, that's what causes the chronic circadian rhythm disruption. The reason is when you shift your schedule even by 3 hours, or if you go to bed 3 hours later than when you typically do, then it takes on an average 3 days for your circadian rhythm to readjust. And if you do it just once or twice a week, that means for half of the week or even for the entire week, your body is just trying to play catch up, because 3 days in one way and 3 days in another way. So that's what causes the circadian disruption. So some of the ideas is people who do shift work, people who get up very early in the morning and going for their early day job, then they should try to maintain similar schedule in the off days, which may not be easy to practice. But people come up with various strategies. They try to incorporate nap during daytime and blackout curtains, etc. So it's possible to optimize your health even when you are doing shift work.
Right. So those are some great little strategies already at the start of this call to help those who perhaps have no choice. You know, they have to work shifts. Yeah. You know, I can think of family members who work in the health service here in the United Kingdom, and they have to do 3 shifts or 4 shifts on one shift, and then they change. And that happens for, 2 or 3 spells before they get a long period of time off to then recover. And that's always seemed to me to be a pretty difficult sort of schedule to follow, because like you said, every few days they're shifting to something completely different. It might be day shift and morning shift. And then they're having to still work in what's a pretty high stress demanding job. Is there evidence to sort of show that those kind of changes and shifts, because the fitness industry do that as well. You'll have people who have to open the gym at 6 a.m. and then other shifts that don't start till 3 p.m. What's the evidence around the impact on health for those who are going through that constant, roller coaster of changing shift?
Yeah, so that's what I was telling you, that there is a rich literature of detrimental effect of shift work on health.
What sort of things? I guess I'm asking for this. What sort of things do we observe? How does that affect their health?
So this can be in many ways. So for example, people who do shift work, they have more gut problems, stomach problem, indigestion, and shift workers who work many, many years in this night shift or day shift, is switching back and forth between shifts, at a high risk for various kind of colon cancer and gastrointestinal cancer. We also know that shift workers are at a high risk, particularly firefighters, who sometimes do 24-hour shift. Actually, very often they do 24-hour shift. They're at a very high risk for cardiovascular disease. In fact, the number one cause for death or disability at work is not firefighting, but heart diseases.
Really? Wow.
Yeah. And many shift workers who are already diabetic, they may find it more difficult to control their diabetes even on the same medication as non-shift worker. And then the list goes on. Shift workers are also highly prone to affective disorders such as depression, anxiety, One may say that that may be a result of the stress, but at the same time, I think it's an interaction between stress and your brain not being prepared to take that stress, because a day shift worker may be able to take that stress and the night shift worker may not. So this brings up a big societal debate because, we have been living with circadian rhythms for the last 200,000 years, but only in the last 25 years or so, the molecular biology, the physiology, metabolism, brain function, how they're affected by circadian rhythms, and how circadian disruptions disrupt this normal health has come to light. Mm-hmm. And to be very clear, the ultimate goal of biomedical research, fitness, all of our effort is to let everyone live their peak physical, mental, and emotional health, irrespective of age, gender, ethnicity, or nationality, or health condition. And this is kind of a universal human aspiration, and you can say universal human right. In fact, sleep disruption is considered to be unethical, even during interrogation. So in that case, the big societal question is, can we come up with some guidelines around shift work so that we can have science-based evidence-based practice in shift work, where the shift workers can stay on the same shift, say, for 2 or 3 weeks before we change their shift. And I hope that this discussion will come into play. People will start to take science and maybe discuss that among their colleagues or unions and bring up to their employers. And hopefully soon we'll see that happening.
Yeah, I'd like to see that happen in the fitness industry as well, for sure. In my early years, I definitely did quite a lot of changing of shifts midweek, and it's challenging on the physiology, definitely.
Yeah.
So we're going to switch gears now a little bit and talk more about time-restricted feeding. I know this is a subject that's close to your heart, and you spent a lot of years focusing on this particular subject. So perhaps could you first define what we mean by time-restricted feeding?
Yeah, so this is a concept that was developed in my lab almost 10 years ago, and subsequently in popular media, it became intermittent fasting. So the reason why we called it time-restricted feeding was when we initially did the experiments in rodents and lab animals, we gave mice access to food for 8 hours to 9 hours every single day. And they could eat the same number of calories from the same food source as the mice that had ad libitum access or 24 hours access to food. So in this case, since we are not reducing calories, so we are not doing any dietary restriction or calorie restriction, we're just restricting the time when they had access to food. We called it the time-restricted feeding approach.
Right.
And in mice, we have done this experiment for 8 hours time-restricted feeding, 9, 10, 12, and 15 hours time-restricted feeding. And, the first experiment was 8 hours time-restricted feeding because of just logistics issue, because we could not systematically probe 8, 9, 10, or 12. But after we published it, people thought that 8 hours is the magic number. So if you talk to most people, they will say intermittent fasting or time-restricted eating means 8 hours eating and 16 hours fasting. Mm-hmm. But actually 9 hours also works, 10 hours works to a great extent. And we cannot study 6 hours and 4 hours without reducing calories in mice, so we haven't attempted that. Right. So the bottom line is try to eat for 8, 9, or maximum, say, 10 hours window within a day. Consistent window, that's much more important, and try to fast the remaining 16, 14, or those hours. Yeah.
Mm-hmm. And that's interesting, because that brings my thoughts. We've been talking a lot about society and how society's changed in the last 25 years. I mentioned 24-hour gyms. There's also 24-hour supermarkets. Huge amount of availability of food from shops and fast food outlets across a vast portion of the 24-hour day in most people's immediate environment. And yet here you're now talking about holding back food intake and an intermittent fasting approach, which is, like you said, a well-known term now, thanks to your research. You're talking about that for only 8 hours and fasting for 16. I imagine many people that wouldn't have even considered that as a typical lifestyle choice. Any thoughts on that?
Yeah, so actually I kind of explained why this is a better idea in my first book, The Circadian Code. You brought up quite a few things. It's actually in our human experiments and mouse experiments, what we find is 8, 10, or even some cases 12 hours time restricted eating is good enough for many people. So that means people can begin to limit their food intake to, say, 12 hours. And if you start thinking about, and another thing is the word intermittent fasting actually makes people who need to fast a little squirmy because they don't like the word fasting. So that's why in our clinical studies, we tell them, well, you can eat whatever you want within 10 hours. We don't use the word fasting. And many people who are diabetic, obese, and have heart conditions, they like this idea. Hey, I can eat whatever I want within 10 hours. So there is some effect of this semantics, how we describe whether it's intermittent fasting or time-restricted eating on the target audience. Mm-hmm. Second, how to explain this? So for example, we all know that we have circadian rhythms in brain that tells us when to sleep. Similarly, over the last 25 years, we and others, many scientists have discovered that there are also circadian rhythms in our heart, gut, stomach, lungs, in almost every organ. So that means just like our brain needs to sleep for 8 hours to repair, reset, and rejuvenate so that we feel much energetic, fully rested the next day. We are very productive. Our brain power is high. Similarly, to boost our stomach power, liver power, we have to let these organs rest, rejuvenate every single day for at least 8 hours. So then the question is, you'll say, well, if they have to rest for 8 hours, why are you fasting for 12 or more hours? The math is very simple, because after your last bite of the day, which can happen at, say, 6 o'clock in the evening, although your mouth finished its work, your stomach has to work for next 4 to 5 hours at least. And then your intestine still has to work afterwards. So that means, although you finished your dinner at 6, your stomach is not going to get rest or its sleep till 11 at night. And then if you add 8 hours rest to the stomach, then you can eat only next day at 7 o'clock or later. So now you can see how by avoiding food for at least 12 hours and ideally say 14 hours, you actually let your organs to have that restful, rejuvenating, you can say, sleep. Mm-hmm. And that way you can keep all your organs healthy.
Yeah, that was really well explained. I like that idea of mapping it out to say, you know, when you eat, there is still sort of 3 to 5 hours of digestion going on before that organ's going to stop. And it made me think of those who might like the idea of a snack right before bed. They might eat at 10:30 or something like that, go to bed at 11. Well, they're digesting away until 4 in the morning. And like you said, by that point in their sleep process, you know, cortisol and other hormones are starting the process of beginning to prepare to wake up. And so the organs don't actually get much of a break. So I think that was really nicely explained. Now, you mentioned your book as well there, The Circadian Code, the original one. Now, obviously, you've just published your next book called the Circadian Diabetes Code. Let me get it right. And in that one, you mentioned something I think it would be very interesting, because the book talks a lot about metabolic health, in particular diabetes mellitus. But you mentioned that there's 3 foundations of health, and I think this will springboard us to some other thoughts. And those foundations to health that are connected to circadian rhythm, we've kind of touched on, but they're eating as being one of those stimulus of circadian rhythms. They are sleeping and their physical activity. Can you just explain how these 3 interplay in relation to metabolic health?
Yeah, so all 3 are key to our metabolic health. Of course, nutrition, we need different nutritions to fuel our body. And as I mentioned, we have to eat again, within certain number of hours so that our body can repair, reset, rejuvenate. And actually another thing is when we eat within a fixed time and within a fixed window, then that boosts our circadian rhythm. That means all the rhythms in our brain and body stay synchronized and stay robust. Then we go to physical activity, and we know that the largest organ in our body, largest tissue type is muscle and connective tissue. And just like we need to use our brain to stay sane, similarly, we have to use our muscles and connective tissues for health, because only when we exercise, our muscles produce various types of hormones and various types of repair molecules that travel to other parts of the body and brain to nurture them. And in fact, recently, only in the last 3 to 4 years, scientists have shown that when we exercise, that sends some signal, we don't know what the signal is molecularly, to the brain, so that our brain can fall asleep at the right time and can go into deep sleep. So exercise has many, many benefits. And in fact, physical activity, exercise is one of the best medicine you can say for many diseases. Even people who are going through cancer treatment, some moderate exercise can accelerate recovery. And we know that people who had heart disease or want to prevent heart disease, exercise can also help. That brings us to sleep. Although we think that sleep is just a vegetative process where we just lie down in the bed for 7 to 8 hours, there are actually a lot of repair and rejuvenation happening during our sleep. For example, our brain produces a lot of toxins during the daytime, and new evidence shows that when we sleep, these toxins are taken out just like the garbage truck comes and takes out all the trash from your neighborhood. Similarly, during sleep, that detoxification happens. Second, our synaptic connections, so the connection between neurons, strengthen during our sleep so that we can make new memories and retain those memories. And then the third thing is during sleep, our brain also produces many hormones, including growth hormone, that helps the rest of the body to repair. So for example, our stomach lining needs to be repaired almost every day, because during the digestion process, we lose 5 to 7% of cells in our stomach lining. So it's almost like a highway getting damaged every single day. And you want to repair that highway, repair the stomach lining, because unless you repair it, maybe undigested food particles and bacteria and other stuff can leak from your gut into your bloodstream and cause systemic inflammation. And during the sleep process, the growth hormone secreted from our hypothalamus can travel and help that repair process. So in this way, we can see that sleep, physical activity, and nutrition play a huge role in all aspects of health. So that's why I say lifestyle is what, when, and how much we eat, sleep, and move around or do exercise every single day. And by just paying attention to these three aspects, we can stay healthy and live a very long, productive life.
Fantastic. That was a great overview. A really good way to connect those three particular pillars. And we certainly refer to them in our business as the pillars of health. Now, something that I'd like to get into a bit more is how the physiology changes when we sleep well, eat well, and exercise well versus someone who does not. You know, we have epidemics of obesity and diabetes in society at present because metabolism is altered. You know, blood sugar is typically too high, blood cholesterol levels often elevated beyond where they should be, body shape changes. All of those things happen to show significant imbalance in the metabolic parameters or the metabolic systems of the body. If we start to dial in those three things and eat at the right times, exercise at appropriate times and sleep with the light day cycle. I want to know, how could that change? So if we had someone who was diabetic or obese, how would their metabolism change as they dialed in those three foundational pillars?
Yeah, so that's a great question to segue to my next book, the Circadian Diabetes Score, because that's where I discuss how these three interplay to optimize our physiology and metabolism. So let's start with sleep. We know that somewhere between 7 to 8 hours is optimum number of hours everybody should sleep. So to practice good sleep, one thing that people can pay attention to is going to bed at consistent time, bedtime, because when you change bedtime by more than an hour or two, then that is not good way to nurture your sleep health. So go to bed at a consistent time and try to be in bed for 8 hours. So that's the magic number, to be in bed for 8 hours. And if you try to be in bed for 8 hours, then hopefully you can get 7 hours of restorative sleep. And when we don't get enough sleep, then we know that next day we feel cranky. What is crankiness? That means we cannot process the incoming information to our brain and we cannot react accordingly to the information. And as a result, we make bad decisions. And in a day, irrespective of who you are, what kind of job you do, and what your health condition is, there is one type of decision we all make, and that relates to food. We make more than 100 decisions in a day about food: what to eat, how much to eat, what combination food to eat, when to stop eating. And all of these things get messed up. So as a result, people have shown, scientists have shown, that a sleep-deprived brain can crave for more food, and also energy-dense food or bad food, which may be high in sugar and fat. So in that way, by maintaining a good sleep hygiene, sleep health, you also have a better control over your choice of food, because to control diabetes, to control many metabolic disease, we have to have control over food. And we can get that control indirectly by sleeping well. Now, second, coming to food, actually the new circadian rhythm research has shown a link between melatonin and blood glucose. And this was very surprising almost 15 years ago, when genetic studies started to show there is a connection between a certain mutation in melatonin producing enzymes and melatonin receptor and diabetes. And only recently that has been clarified that just like melatonin, that the nightly hormone that many people take to sleep, that naturally goes up at night in our body, it makes our brain to sleep. Similarly, melatonin also makes our pancreas to sleep. Mm-hmm. So that means when we eat, particularly food that has a little bit of carbohydrate, then a pancreas has to produce insulin to better process that carbohydrate or sugar. Mm-hmm. And when melatonin levels are high, then our pancreas cannot produce enough insulin to take care of the sugar. So that means melatonin levels actually rise 2 to 3 hours before we go to bed, and it falls, and it can take 1 or 2 hours after we wake up for the melatonin levels to fall to low level. So that means after waking up, we should wait at least 1 to 2 hours before our first meal, because if we eat too close to waking up, then our pancreas is not ready to process that carbohydrate, and almost all of our food has some carbohydrate, and it doesn't take too much carbohydrate. Just 1 or 2 grams of sugar or carbohydrate is enough to trigger the pancreas to produce insulin. So it's better to wait 1 or 2 hours after waking up to have your first bite. And then, as I mentioned in both the books, the Circadian Code and the Circadian Diabetes Code, time restricted eating or intermittent fasting, whatever you call it. But if you try to limit your food intake for 10 hours, 12 hours maybe to begin with, and if you're living with diabetes and taking certain medication, you should consult your doctor to see whether you can do 10 hours or 8 hours eating and the rest of the fasting. So try to eat within that many number of hours, because there's some simple math. So for example, if you eat only within 10 hours, then for 14 hours, your body is not seeing significant amount of blood glucose. So your nightly blood glucose or overnight blood glucose control will be much better, because you're just not eating. If you don't eat, then your blood glucose will remain low. All because for many diabetics, only after we eat, our blood glucose level goes up, and it takes a long time to go down. The indirect way is when we eat within certain number of hours, then for the first half of that eating window, our body has enough insulin, because some people produce less insulin. For them, there is good amount of insulin in the first half of the day to process your food and maintain your blood glucose. And for others who don't, who produce sufficient insulin, but their body doesn't respond to it, we are seeing that somehow this intermittent fasting or time restricted eating improves our insulin sensitivity. So that means even in the presence of insulin, our body becomes sensitive, so we can process that blood glucose. So that's the second thing that we can incorporate: 8 hours of sleeping, wait for 1 or 2 hours in the morning before your first bite, and then maybe start with 12 hours of eating or 10 hours of eating ideally.
Yeah,
and then so then the question is, when do you exercise, and how does exercise fit into this? Everybody should exercise, because when we exercise, our muscles can soak up some glucose even without any help from insulin. And this is something type 1 diabetics have noticed, that when type 1 diabetic athletes, for example, they are physically active, they're going to the gym and practicing or training for some event, then they need less insulin to control their blood glucose than when they're not active. And this is a very common knowledge among many type 1 diabetics. So we know that just by activating your muscle, by moving around, you can process glucose much better than not exercising. But now, if you are pressed for time and you have only, say, 30 minutes to exercise, then how can you get the big bang for your buck? So only recently, again, only in the last 4 or 5 years, scientists have discovered that in both laboratory animals, humans, healthy humans, and also among type 2 diabetics, that afternoon or evening exercise is much better in controlling blood glucose than morning exercise. So for example, in a famous study from Karolinska Institute, the scientists put few type 2 diabetics through high intensity interval training in the morning, and then the same individuals, after 2 weeks of washout, they're again put on the evening high intensity interval training, the same exercise routine. And conversely, there was another group who started in the evening exercise and went to morning exercise. And surprisingly, they found that when this type 2 diabetics exercised in the afternoon or evening, they controlled their blood glucose much better than morning exercise group. Even within the same individuals, when they did morning versus evening, then evening exercise was much better. And this is really exciting, because now people can schedule their exercise schedule to late afternoon or evening. And particularly for those with type 2 diabetics, maybe after the last meal, because if you exercise right after your meal, then it's almost like a diabetes medication. You can reduce your blood glucose much faster. You don't have to, your blood glucose doesn't have to stay high too late into the night. So in this way, people with diabetes can incorporate sleep, time restricted eating for at least 10 hours, and then some afternoon or evening exercise into their schedule to better control your blood glucose. And in our clinical studies, what we find is when people have high blood pressure, those who are taking blood pressure medication or not, if they just try to practice 10 hours time restricted eating, then the body controls their blood pressure much better than without time restricted eating. And it's not due to weight loss, because we have done that calculation, and other researchers have also done even more controlled study. For example, Courtney Peterson from University of Alabama has done a very beautiful study where she counted every single calories and fed human subjects, volunteers, within 12 hours or within a shorter interval of 6 hours, and found that without any weight change, people who eat within short interval, they control their blood glucose, blood sugar, blood pressure, much better than those who don't. So this is another way people can control their blood pressure. And this is becoming more important because, at least in the US, nearly half of the adults now have high blood pressure. I mean, more than what is ideal. Yeah, sure. And similarly, nearly half of the adults in the US have pre-diabetes or type 2 diabetes. So in this way, by following a ideal circadian rhythm, by paying attention to sleep, physical activity, and eating time, I think millions of people can improve their health and stay healthy for more number of years than without doing it.
Fantastic. Now, I've only got a couple of remaining questions, because in that block you answered so many great things. You're starting to paint a picture of how somebody should live and when they should eat, when they should train. This is for metabolic health, is all very fascinating. The one question I wanted to ask here is, does it matter at what point in that 24-hour cycle that let's say they started with a 10-hour time restricted feeding block? Does it matter when they start that? For example, somebody who starts at 7 in the morning versus somebody who starts at 11 in the morning. Is there any research that's been done to show a difference in the effectiveness of the effects?
Yes, unfortunately, there is no direct comparison, although there are some papers that claim early time restricted eating is beneficial, but in the same papers, there was not late time restricted eating intervention. So it's a little bit confusing. So as I said, one rule of thumb is after waking up, wait for at least an hour or two before your first bite. So that means when you say starting 7 a.m., but if the person is waking up at 6:30, then that 7 a.m. starting is too soon. So one rule of thumb is try to have 1 or 2 hours wait time before wake up. And the converse is also true, because as I said, 2 to 3 hours before we go to bed, our melatonin levels begin to rise. So that means your last meal should be 2 to 3 hours before your bedtime. So now that gives you a very rough window in which you should choose your eating window, because if you're in bed for 8 hours and in the morning you are waiting for an hour, and before going to bed, if you have to wait 2 to 3 hours, then that takes care of almost 12 hours. So if your bedtime is at 10 o'clock, then you should not be eating from, say, 7 p.m. onwards. And if you're waking up at 6 a.m., then you should not be eating before 7 a.m. So that means you have a window from 7 a.m. to 7 p.m. and during which you can choose your 10 hours window. So now coming to real societal impact, or, the other effect, because we don't live in isolation. We are social creature. We hang out with friends and families. So then what happens is, if you're likely to eat early and then end early, suppose say you are finishing your dinner by 6 or 6:30 or 7 p.m. in the evening, versus someone who is starting at 11 a.m. and ending at, say, 8 p.m. or 9 p.m. doing 10 hours time restricted eating, then the person who is ending late is more likely to be offered alcohol and after dinner dessert. So then you're more likely to drink alcohol and consume some extra sugar than somebody who is finishing early. So that's what we see when people do time-restricted eating. We do see people reduce their alcohol intake. And in this cohort, we mostly had people who are finishing dinner before 8 p.m. So it'll be interesting to take another cohort that ends later and then see whether that alcohol intake and other unhealthy diet goes up if they end this window a little later at night. So that's just the practical in the society, what really happens.
Yeah, that's interesting. That's an interesting side effect for sure. It brings me to one last thought because I know your time is short now. And that is one of the challenges for many people who are obese and who are diabetic is the persistent urge to snack or the cravings that might bother them throughout the day. Have you observed in those who've gone through maybe an 8 or 10 hour time restricted feeding window, does that help or assist with the cravings that they may experience because they get used to going for periods of time without eating, or is that still potentially a problem?
Yeah, so we tell our participants that the first week or two is really tough because their body is used to looking for food every 2 to 3 hours or maybe every 1 hour, and they have to control. So they have to go through that first 1 or 2 weeks when they adopt, say, 12 hours or 10 hours time restricted eating. People who are going through 8, even for them, it's a little bit harder. But after those 1 or 2 weeks, then some practical things also happen. That is, after going through 14 hours of overnight fast, when these people start their breakfast, they tend to increase their breakfast size. So that means they're eating slightly more in their breakfast than before. And many people also try to eat a little healthy because, out of all of our meals, perhaps breakfast is the only meal for many people over which we have complete control because we can eat at home. And then once you get out of the home, you don't have much control over your food. So once they have a healthy, big breakfast, potentially with a little bit of extra fiber or fat or protein, then that reduces their hunger for the next 4 or 5 hours or even 6 hours. So they don't have the urge to snack. So the morning snacks are gone mostly in a lot of our participants. And then in the afternoon, after a small meal, lunch, they're actually looking forward to a good dinner because they know that their eating window, the kitchen will close after 10 hours. So, and you want to finish the day with a good dinner. So they kind of look forward to that. And they know that if they snack a little bit, then they may not have that hunger. Then they'll eat little small dinner, and then overnight they'll have hunger pangs. So they kind of learn this from their daily routine. So slowly snacking reduces, and then they increase the size of their meals, particularly the breakfast meal.
All right, fantastic. That's very useful to know because I'd imagine anyone who's trying to initiate a period or a habit of time-restricted eating, they may be worrying about some of those things. And so to hear that those are normal changes that to occur, I'm sure is quite encouraging. Is there anything else you would like to add based on anything we've talked about today? I mean, maybe, any more key things from your book or thoughts that might tie up what we've talked about today?
I think we covered most of the topics that relate to the first book, the Circadian Code, or the second book, the Circadian Diabetes Code. Of course, we cannot go over all the topics. For example, there is a huge impact of light and how to control light, how to manage light to your advantage. But let's end with this, a challenge. And the challenge is this, because recently my daughter went to college and I saw many of my daughter's friends, they went to college. And when I look around during my daughter's high school graduation, and also when I look around among my friends, I realize that a lot of my friends and a lot of my colleagues, when we all reach 50 or our kids go to college, nearly half of us are on some medication to manage metabolic disease, whether it's blood pressure, cholesterol, or blood sugar. So just think about it. Can we take a challenge that we should stay healthy at least until our kids go to college? At least until then, we should not be on any medication to manage chronic disease. And in fact, by following the circadian code, when to eat, sleep, and move around, I'm very confident that millions of people can actually meet this challenge to stay healthy without medication until at least the age of 50.
Fantastic. That's a great challenge and a great way to end the show. It's been such a pleasure to have you on, Dr. Panda. Appreciate your time. And in the show notes, we'll, of course, link up our listeners to both the Circadian Code, your first book, and the Circadian Diabetes Code. And I highly recommend it. It's a great read with some great insights. So thank you very much again for your time. Have a great day.
Thank you, and have a perfect circadian day.